So Taylor, then there's a question 2 on this question paper, which is you have covered. Then question 3, now we have covered. For February 2022. Sir, oh, libonile na? Bonile na? Okay, iti pa ng 1.3 na. It is the no load current drawn from the supply by a 450 volts DC shunt motor. Okay, guys, when you are talking of a shunt machine, you must always be aware that, okay, the question could be asking about a speed control or a Swinburne, because the Swinburne method is either sithetha the compound machine or sithetha large shunt machine. A Swinburne test, you don't use a Swinburne test to test a series machine. Yeah, but immediately you have a series machine, a motor, that is speed control. Ana? Even a back-to-back test, the second test, back-to-back test, that is also a what? A, a shunt or compound machines. Ne? The only test engane series intoni a brake test, rope brake test, of which is it's unlikely bayaphuma questions. Yeah, it's no longer part of the syllabus or what. A rope brake test. And funny bona but ningayithekisa is very simple. It's like ingathi science. Okay. Then particularly no load current IL1 is 12 amps. The armature and shunt resistance RA is equals to 0.5 ohms. Then R shunt is equals to 240 ohms, respectively. 1.3.1, calculate the following. The output of the motor, sithetha a motor, ne? The output of the motor, if the armature current is what? 55 amps. Okay? IA2 lower, ne? So, bafuna output power, ne? And what are we talking of? A motor. Ne? So we cannot say power out is V times I. Because the motor power out is non-electrical. Not electrical. Okay. So what we manipulate this formula. Power in equals to power out plus what? Losses. So I need to know my total what? Total losses. Yeah, ma? And what else do I need to know? Power in, yeah? Power in, input power. Okay, input power, we can say UV. Am I making sense? Because input power of the motor is what? Electrical. Ano? So a power out is given by power in minus the total what? Losses. Ano? Okay. So let us calculate power in. Power in is what? 450 times 1, times 1? 12. Okay. Okay. Okay, guys. This is input power at what? At no load, sorry. That is input power at no load. Nah? Because we are using one, the no load what? Current. Why are we using the no load values? The no load values is for us to calculate in one, the ion losses, nah? Nah? Okay, let us go to page 39. The ion and friction loss at no load. The ion and friction loss we calculate it as what? At no load, and it is a constant loss, nah? It's given by power in at what? No load. So power in at no load. Okay. Uh, power out at no load, man. Power out at no load. 0, yes. Okay, minus 0 plus B I shunt. Okay, shunt loss now you don't constant what? Loss. Nah? Then in the A variable loss in one amateur copper loss. Nah? Plus amateur copper loss at bani. Amateur copper loss at no load. Yabo. Usually, okay, I've seen memos they ignore in one the amateur copper loss at no load. Yabo. Yeah, kushiyane nje. So i-final answer yakho ishiyane nge-decimal. Yabo. Okay. You will see. Okay. So, what is the no load loss man? 45, 400 man? Oh, 5,4 kilowatts. Ano? So 5,4 times 10 to the power 3 minus 0 plus 450 times Bano I shan't Ohm's law, which is 450 over 240. What is I shan't? 1.875 amps. Niyabona why i-copper loss, i-shunt loss change is because current is always what? Shunt is always the same. The only time we could change it is when we change, supply what? Voltage. Or we change resistance, we shunt circuit. Times 1,875 plus bani amateur copper loss at no load. Amateur copper loss at no load. Amateur copper loss at no load. Scatter motor for IL minus bani. Aishan. Make sense, na? Okay. Motor most, na? IL bani 12. Then Aishan bani 1,875. To 10,125. So, na? Okay. So, spend on 10,125 squared. RA. What is RA? RA is 0,5, na? Ion and what? Friction loss equals to bani? Guys, last zero ne ulapha ne kule formula umele intoni? Power out, na? So basically then I assume what? Then test. Punch it. Bye. Bye. 4,505 kilowatts. Those are our ion and what? Friction loss. Okay. Now, total losses zethu, total losses zethu zingaphi? Total losses zethu ziyi-3, ana? I-shunt copper loss, ana? Ibe yi-amateur copper loss, ibe yintoni? Ibe yi-ion and friction loss which we just calculated, ana? So total losses total losses i-ion, ana? Okay, plus ion and friction loss, na? Bani shunt copper loss. Shunt copper loss mass is given by P times I what? I shunt, or you can say I shunt squared times R shunt. 450 times bani 1,875. What is the answer? 8, in kilos, because we have placed everything in kilos. Oh, unless we know we're not so small, né? Okay, if it's so small, let's do like this. Let's say times 10 to the power 3, yeah. Kubanding 800. Uh, sorry, 0.75 watts. Okay, 843, na? 0.75 plus. Indone new loss kanene? Amateur copper loss at what? Full load. Ana? Which is IA2 squared R bane? RA. What is IA2? Think we're given 55. So 55 squared, then what is the amateur copper loss at full load? 1000. Okay, 512, comma, huh? 0.5, na? So money total loss is guys. 6, 8, 6, 8, 6, 1, comma 2, 4. What? Okay, those are my total losses, na? Now we can calculate output power. Output power is given by E power in, na? E power in at load, not power in at no load, na? Power in at what? Load. E power at low at no load was only used to calculate the ion and what? Friction loss. Yeah, but what about the calculate power at this current? Ana? Amateur. Okay. Current. So for now current I add by 2. Ana? Ko I A 1. Oh, sorry, IA2, sorry. This one, this IA plus bani. I shunt. Okay. Which is 55 plus 1,875. 56,875 amps. Okay, minus the total losses. That is basically 450 times 56, 875. minus eza losses bani 6861,24. So i-power out ngubani? What is power out? Okay. Ingayibeka in kilowatts, it's fine. 18.73. 18 point. Okay. 18. 18. 3. Ah. 3 kilowatts. Fine. Then enye ithi ifuna the what? Efficiency of the motor if the armature current is what? 55 amps. So guys, the armature current wasn't changed. Must be very careful. Sometimes they will change it. That means you have to calculate the output power enjani and because if they changed the armature current, that means OI load what changed. Anna? Okay, still that's 55. So output power at 55 nans. Yeah. Then input power nans. Anna? So we have input, you have output. You can simply calculate efficiency using the normal standard efficiency formula. Power out over power in times bani 100, which is power out is 18,77 your 733. Power in yena bani 450 times 56,875. Tell bigger in kilowatts. 25,5. Sorry. 94. Okay. Kailan balele yung percentage yung bani? 73.2. Question elandelayo ithini? Armature current at what? Maximum efficiency. At maximum efficiency, constant losses is equals to what? Variable what? Loss. Okay. Of which is the constant loss esinayo yi-2, then i-variable loss esinayo yi-1. Constant loss esinayo yintoni? Shunt, ferro copper loss, plus ne-iron and what? Friction loss. Then ibe yintoni? Armature, let's call it I3 this time because the representer as intoni? Current, armature current at what? Maximum efficiency. Great. Yabo. Basically what we want there sifuna bani? IA3. Okay. So IA3 is equal to square root shunt copper loss bani. What's it by? Yes. Nanti. 843,75 plus iron and friction loss bani. It's 4,505 times 10 to the power bani 3 minus sorry, is it minus or divided divided by bani RA, which is bani 0.5. You square root everything, guys, no? It's like solving for x. You first divide by la RA, then you square root everything. What is I? A3? Sorry. What is I3? Square root everything. But 103, comma 429 amps. Okay. So that is basically our amateur current at what? At maximum efficiency. Then bafuna ntoni? Maximum efficiency, na? That means we have to calculate IL ohms, na? Okay, because we are not at 55, we are at, you know, biology. Ah, eh, it is itsho abalentsha. Nantsi nje ikhona. Intoni? Siyenzile nje. Nantsi. Yabo? And benze a mistake on that memo. Benze ekuqaleni. This is not how you calculate amateur copper loss, guys, please. Irongo. Imemo zibalwa ngabantu. That is not how you calculate a copper loss. A copper loss is a function of what? I squared and bani? Ah, yabo. So they made a mistake. Because what voltage times current. Mm, mm. Uyayibona no? A copper loss is a function of current and resistance. Yeah. Um, sorry? Even either way, look at page 39. At full load, but at no load, by times a current and a voltage. You know? Yeah. At no load. Sorry? Yeah, friction loss. Oh, Input here friction loss. Okay. Doesn't appear in the textbook, Londo. Hmm? Londo. Ayikho nje. Undoni input armature. Input to the armature at no load. Okay. If you input to the armature at full load, yeah. At full load copper loss. Mm-mm. Mm-mm. Guys, i-losses i-losses esinazo phasi ziyi-three. Yabo? Bona they having four. Yabo, basically. I-losses esinazo phaya ziyi-three. La loss thina si-includile i-amateur copper loss at no load. Nansi khona kuformula. Ntwana siyifunayo. Yasinceda safumana ntoni? Iron and what? And friction copper loss. Yabo? Okay. Then we got iron and friction copper loss ne. Using also intoni amateur copper loss at what? At no load. Ne? Then sabale amateur copper loss at what? At full load, because the iron and friction loss, the constant losses. Yeah. Uh, so basically, what we should have done, Tina, we ignored total losses. Pago total losses we ignored in no load copper loss. Masi include Basiti, but no load copper loss. Put 10 comma times 0 comma bani 5. That means with textbook they ignore it because it's negligible, it's small, ne? Uzobang bani total losses. So I'm sure that is the only difference. Ungalibali uthi squared, ne? Or basically ungathi le value times bani plus this value plus 10 comma 125 squared 0 comma 5. 6912 comma 508. Iyafana yango? Huh? Iyafana? Huh? Iyafana, ne? That means on the textbook they ignore le nto bendiyithethile bendiyivezile ekuqaleni. On the textbook, I wasn't able to recall which one was which. Was it the textbook or the question in the question papers? Yeah, but the textbook ignores when it accounts for total losses, it only accounts for what? 3, whereby it should be accounting for what? 4, including the amateur copper loss at what? No load. So guys, cela niphinde niyondibalela ke ni-include ntoni laa nto izoyibona ke zizothini zizofana ii-values ne niyambona umahluko. Okay, so guys, we'll meet on Monday. Okay, Monday. Good night.